things in calculus that they give it a name, they give it a definition, but it just makes logical sense, and you'll see why in just a minute. But you do have to be able to state the name of it. There's been a lot of questions on if you can abbreviate on the AP exam, as far as like if it says justify your answer, and this was your justification was the extreme value theorem, if you could put EVT or not. And you can, but it's not good practice, because if you mess up with some letters, like if you were to put ETV instead on accident or something like that, you lose full credit for that. So they say to go ahead and write out extreme value theorem, but whatever. All right, so extreme value theorem is really, really easy. But you'll see how we'll apply it every which way to tomorrow, and then it won't be quite as easy. It says that if I have this function f, and f is continuous, remember how we always have to show the background and the requirements before? Like we have to show, like if we're saying that it's continuous, we have to show that it's the limit's the same from the left to right function. So this is the same kind of thing. If f is continuous, and here's the important part, on a closed interval, what does that mean? Okay, it does include those 2 points, but what does that, what, nobody knows what that means. So if it's continuous on a closed interval, that means it's cut off on that interval. So if I'm just looking between here and here, maybe this is A and this is B. So if my function is continuous on this closed interval AB, then my function must have an absolute maximum and minimum. Does that make sense? There has to be a very highest point. There has to be a very lowest point. Okay, but here's the kind of strange thing. Hi, Stella, by the way. I told Stella I'd say hey to her if she wasn't here today on the recording, because she said she took today off.
Oh, she probably has it. Oh, she was just like, that's it. That's a good idea.
Mental health day. I think it's every, yeah, I think so. You probably just have to go get it. But if I'm cut off from here to here, then it makes sense that there's a very high and a very low, right? Does that make sense to you? The difference is on these, as I'll do sign analysis again, right? I need to make sure that I check the endpoints. This doesn't go with the definition. This is just me telling you. Always check the endpoints to see if they are the absolute maximum or minimum. Let's with the exception of endpoints. Tell me what happens in terms of derivatives. Robert, don't even look at me. In terms of derivatives, what happens at these maximums and minimums? With zero. That's exactly right. So those are at our local maxes and mins, because they don't have to be extreme, right? Remember, my derivative is always going to equal zero. So if I come in at this is a local max, right? It might not be the absolute max. In this case, it is. But here, my derivative would be equal to zero. Same here. Not endpoints, but yes, at those maxes and mins. Does that make sense? Mm-hmm. The derivative. What else happens when the derivative equals zero? What do we say? This is critical. It changes direction, maybe. It's at rest. So when this happens, and we think about particle motion, we start talking about it being at rest. In general, what we call them are stationary points. So a lot of this is going to feel like things that we've already done. And we start giving it some new, more sophisticated names. All right, derivative equals 0, stationary points, may or may not be a max or a min, but I know for sure if I look on the graph and it's a max or a min that the derivative is 0 there, right? Everybody okay there? All right. What shall we do then? You think? You ready? Well, Robert's ready though.
Oh, really? I haven't been to Walboro. I don't even know where that is. Well, yeah, it's named after a cigarette company. It's so good.
Find the absolute max and mins on this closed interval.
Can you repeat that?
Find the absolute max and mins on the closed interval, -2, 3. No calculator on this one.
When in doubt,
Sure. That's exactly right. That is exactly what I would do. I was sitting here going, why do y'all need to graph that? What are you doing?
You set it equal to 0?
Yes. Why are you setting it equal to 0?
Oh, because did you say that already?
That's right. Maxes or mins happen when the derivative equals 0. Now, here's the thing.
Wait, you just plug in -2.
But here's the problem, right? That's never going to be 0, right? But you know what, well, okay, I hope you know what this graph looks like.
Absolutely.
To the 2/3.
I did not.
Okay, use your calculator and graph.
The square root kind of has that thing.
Mm-hmm.
You know, it kind of has that.
Right. All right, so here's the problem, right? This looks like this. I'll give you a second to graph it so you can see it on your calculator. You don't have to just believe me. You believe me? Mm-mm.
Yeah.
This is very obviously a minimum,
But
right?
that's not what mine is graphed.
What does your graph look like? Did you put your 2/3 in parentheses?
Yeah, I'm right. But it might be like, yeah, that is not what mine is. It does a loop, you know.
It is what?
It's like it's like this. Like this. You know? Oh, no, I'm not.
Okay, I'm zoomed in on this, but it does, if you're zoomed out a bit, it's like this. But it's the same.
No, it's the one's above the x-axis.
Okay, did you put the derivative in or the function?
I put 2/3 times
The
x to
function.
the -1.
I asked you to find the maximum of the function. You found the derivative to try to find those points. So,
You're right.
okay, so here's the problem with this, right? I can see that this is a minimum, and let me go ahead and, oh my gosh. I'm going to cut it off because I know it's got endpoints, right? It's between -2 and 3. So I'm really just looking at this little piece of graph right here. Yes? All right. Why, at this point, if I know that that's a minimum, why is my derivative not going to 0 there? What's happening? It's not differentiable. That's exactly right. Why is it not differentiable? That's exactly right. That's exactly right. All right, so this point is not differentiable because it's a cusp.
What's the other one? Corner cusp or what?
Huh?
Oh, yeah.
Did you graph this one? Yeah, graph the first. All right. Here's the issue. We've always said that the derivative equals 0 at these critical points, right? But critical points can also happen when the derivative fails to exist. Okay, and this is one of those examples. So as I test points, if I go back to these critical points, right? Critical points can also be when the derivative does not exist. And this is an example of when that happens, okay? So now not only do I have to test when the derivative equals 0, but I also have to test when the derivative fails to exist. So all these points are my critical points that I'm going to be testing, okay? So to test, I guess I should make a list here for max and min. Come on. Endpoints. When the derivative equals 0, and when the derivative does not exist. Corners, cusp, vertical tangents. They call this a candidate's test in your book. That's not a really official. So let's see what happens. So here, right, the derivative's never going to equal 0. I don't have any of those times. But I do have a time when the derivative does not exist because my bottom can't ever be 0. What would cause my bottom to be 0? X being 0, right? So this is a point that I also need to test. So when I test my candidates for maximums and minimums, I'm going to test, and I'm going to do a little sign analysis. It's easier for me to see. Endpoints And then any place where I'm not differentiable or my derivative equals 0. So that's just 0 for this case. Okay, so how am I going to test it, right? I can look, and I've got the graph on here. So this little hole looking at the derivative to tell what the function's going to do, that's not helping me as much whenever I'm looking for a function value. I'm looking for the maximum value or the minimum value. So what do I need to do to find out if those are maxes or mins? Well, I could find the derivative and I could come over here and say that I know that this is negative and decrease, but that's still not telling me which one is the max, which one is the min, because I've also got these endpoints here. So how do I test? You plug in what number? Not -1, but the specific value. Those actual values, if I plug them in, what does it mean to be a maximum value? What the equation equals when I plug in that x value, right? That is the value of the function. Are y'all following? Y'all aren't following. If I ask you for the maximum function value, that means I want the y at that point. So all I have identified right now is the x, right? I know where it happens, I just don't know what it is. And to determine which one's the maximum, I need to see which one's higher. I mean, can you look at this graph and tell if this one's higher or this one's higher? So how am I going to tell which one's bigger? Plug it in and see which one's higher, right? So f of -2 would be 2/3 -2 to the -1/3. Oh, no, I'm sorry. I looked at the wrong equation. Sorry. Get it together, Stacy.
Wait, and what is the derivative have to be?
Well, it not for this one, it doesn't, but I will have some where I have to test both where the derivative is 0 and where it doesn't exist. Well, no, we have to do this in addition to where the derivative is 0. This just doesn't have any place where the derivative is 0. This is obviously 0. Two-thirds. 1.587. $2.080. So this function has an absolute, and this is where you have to be very careful about how you word it and how you write it. Or the cube root of a negative number is negative, and then when you square it, it makes it positive. Absolute. Did you put it in parentheses? Did you do -2 to the 2/3? I get an absolute maximum of 2.080 at x equals 3.
You only have to test it at the like points they gave you.
You're testing at these 3 types of points. Endpoints, when the derivative is 0, and any place I'm not differentiable. Those are all critical points. Possibilities. How about a minimum? Okay, go ahead.
How do you know? Did you just kind of drew this line?
Because at the beginning I said on the closed interval -2 to 3. So then the absolute min of what? 0 at x equals 0. They will get you with these questions on multiple choice every time where they will say you have an absolute maximum of 3 or you have a maximum you have an absolute maximum of 2.080. You have to know, you have to understand that the function's value is your maximum. This is the x is where it's occurring.
So what was the little
That's how we were testing before. I wanted to show you how it related back to what we were doing. Yeah. So if they just asked me where does a minimum occur, well, that's easy. I can tell them that there is a minimum that occurs here. But they asked me for the absolute minimum. In order to know remember the difference in just a minimum and an absolute is it's absolutely the lowest point. So in order to know that it is absolutely the lowest, I have to also check the endpoints here to see if they started out lower. Does that make sense? These three things here: endpoints, when the derivative is 0, and when the derivative doesn't exist. Y'all okay? Let's try one with an equation. Or a harder equation, I should say. Is this going to have any extreme values, and how do you know? It's got to have extreme. Extreme meaning absolute max, absolute min. Does it have an absolute max? That's exactly right. Does it have an absolute min? Yes. We know these two functions are continuous, and because I'm in a closed, restricted domain, right, then it's got to have absolute extreme values. So find them. Marks that go. You can if you want to. This is technically a non-calculator to say, but it's okay. Go ahead. By the way, while y'all are doing that, I did fail to mention here. Would this be a stationary point? Stationary points happen when? When the derivative equals 0. So no, it's not a stationary point. Even though it's a critical point, it's not a stationary point. Because if I just set this derivative equal to 0, there's no place the derivative equals 0. That's when it stops and it's stationary. Stationary points happen when the derivative equals 0. So that is not a stationary point because the derivative doesn't equal 0 there. The derivative doesn't exist there, which is a little different. To text. Mac did.
I can put in 0.74 and then what do I do?
Are you saying what to what I've done so far?
Yeah, how did you put
What's the derivative of log x?
why would you find the derivative before you need that? The last one. This one we did.
We found it on the last one, but it never equaled 0. Remember, there's three things I'm looking for. I'm looking for endpoints, I'm looking for when the derivative is 0, and then I'm looking for when the derivative fails to exist. So it's going to fail to exist where it's undefined. So I changed this to x to the -1, and then I did power rule. Remember, I'm just looking for points to test right now is what I'm doing. Okay, what does the derivative do here? So I need to know, I've got my endpoints, right? I can test those. Now I need to check to see when the derivative equals 0. Well, the only time that that is going to equal 0 is when the top is 0, right? Which happens when? When x is 1, yes? Everybody okay there? This is when derivative equals 0. But things can also happen when my derivative doesn't exist, when I'm not differentiable, which in this case, look. It's not in your original domain. Right. Because she said here x equals 0, right? But if you look back, are y'all understanding where I got these 4 points right now? Okay. Well, that's what. So now I'm going to look at these points, right? And I'm going to look back and go, okay, my x's have to stay between 1/2 and 4. That one's not. Because that would mean that my derivative, if the bottom of my derivative equals 0, that means my derivative is undefined. Go with me? Right. Is it always going to be 1? You sure? Keep going? Okay. Now all I need to do is test these 3 points. I don't actually have to do a sign analysis for this anymore. If it asked me, is this a max or a min, then yeah, I could do that. I could do a sign analysis and figure out, because all I need to do is see if it changes direction. But I don't actually have to do that. I just have to test these and find these values. So what is x of 1/2? So I'm going back to my original equation. So 1/2 to the -1 plus log of 1/2. F of 4 is going to be 4 to the -1 plus the log of 4. And f of 1 is going to be 1 to the -1 plus log. I know that's 1. This is going to be 2. Log 1 is 0 minus log 2. 1/4 plus log 4. So I'd say you probably need a calculator for that to see what your decimal approximations are here to see which one is max and min. No, because if you look back, what's your domain of your function? Right? This says that this is only going to be between 0.5 and 4. So 1 is here, 0 would be over here, right? And it's not in that domain that I needed. What do you get here for the first one? How about the second one? What? Oh, 1.636. So where is your absolute maximum occurring? At 4. So I have an absolute max of 1.636 at x equals 4. And then I have an absolute min, and you should have both of these, right? Because that's what extreme value theorem says. It's closed interval, so I've got to have both. Absolute minimum of what? 1 at x equals 4. Yes, it is a stationary point because that's where the derivative equals 0. So I have one stationary point at x equals 1. Unless they ask, if they say, is this a stationary point, yes or no. But you're right, this one is a stationary point because it's not. Now, if I was testing 0 also, that would not be a stationary point. What do you think? 3 things. I kind of went around. There's my wacky way of thinking I can pull in what you. I try to relate it back to what we've already done, but you're really looking for those 3 things, right? You're looking for endpoints where the derivative equals 0 and where the derivative is undefined, which you're really looking for fractions in the bottoms of fractions to equal 0 there. Or where square roots are negative, those kind of things that make them undefined. Yes, no, or maybe so. Maybe so. Now remember, if I'm not on a closed interval, I don't have to check. I can find extreme values, but I might not have absolute maxes and mins, right? It just depends on what my function. Let me give you your work. I'll stop. We won't go. We'll spend another day on this Monday. Let's just go 1 through 16 today. The first 10 of them are graphs, and we did number 11. That was number 11 we just did together.